Okay, so this is the third video, and we're going to quickly talk about the properties of ionic compounds and of covalent molecules. Now, all the things that you need to know about the metallic bonds were in the last video, so you can always revisit that or also just use your notes. So, properties of ionic compounds. What you need to know is they are very, very strong bonds. So, they're way stronger than a covalent bond. And because of this, they result in having a high melting point and boiling point. So, melting point and boiling point is the temperatures at which these substances will melt and boil. So, when they turn from a solid to a liquid to and a liquid to a gas. So the temperature has to be really, really high because it needs a lot of energy in order to break up these strong bonds. In order for all of these ions to separate, it needs a lot of energy. Ionic compounds are also hard, and they form crystal lattice shapes or regular geometric patterns. So you can see that in this image here. So imagine that this gray positive ion is a sodium ion, Na+, and this blue negative ion is a chlorine ion or a Cl-. So a sodium and a chlorine ion aren't just going to be kind of by themselves. It's not just going to be one and one. What they like to do is kind of create this geometric structure or this lattice shape where a whole bunch of them are going to kind of group together by electrostatic forces. And these are very, very strong. Ionic compounds are also electrolytes. So I'm sure you've heard of the term electrolytes, like we have our Gatorade and our liquid IV and things like that. So what an electrolyte is by definition, is something that separates into ions in water and conducts electricity. So ionic compounds are electrolytes, but only as AQ. So AQ stands for aqueous, which we've seen a few times before. This AQ means that whatever substance it is dissolved in water. So if we had NaCl AQ, that just tells us it's sodium chloride dissolved in water. So when these ionic compounds are dissolved in water or are aqueous, they're actually going to separate into their ions, into their charges, and be floating around on the water. And because they're charged and they're floating around in the water, that's what enables them to conduct electricity. It's important you know that they cannot conduct electricity as a solid. So if you have your NaCl, which is regular table salt, you know that table salt that you put on your fries, that's not going to conduct electricity. But if you were to take that table salt, dissolve it in some water, then that aqueous solution would be able to conduct electricity. So it's important that you know that ionic compounds can only conduct electricity if they are dissolved in water. We're going to talk more about electrolytes, by the way, in our solutions unit. Okay, so properties of covalent bonds. So covalent bonds are weaker than ionic bonds. And because they're weaker, that means they have low melting and boiling points. Therefore, their molecules require less energy to kind of break apart and split apart from each other when going from different phases. Covalent molecules do not form electrolytes, so they do not conduct electricity when they're dissolved in water. And covalent compounds are typically soft. So some examples of covalent molecules you can think of is like DNA, plants, or the water that we drink. Okay, so this is pretty much all of the stuff you need to know about the properties of ionic and covalent molecules.